Okay, welcome to another episode of Teach Me EGD with your host, Mr. Govender. Today we'll be doing a grade 10 mechanical casting example. So I'm using an older version of the JPEGD booklet. So your page number might differ. Mine is page 45, but I will confirm what the new page is in the latest booklet, which is I think the 9th edition. So let's get started. This is a mechanical casting. I'm just going to spend some time explaining what this is, how to interpret it, and how to start drawing. So let's read the given question. Okay, so what is given to us? The exploded isometric drawing of the parts of a pulley assembly. Okay, so it's a pulley assembly. The highlighter. Okay. Showing the position of each part relative to all the others, orthographic views of each part of the pulley assembly. Okay, so these are orthographic views that are given to us. Okay, front view, left view, front view, left view, front view, left view. Okay, or left view, front view, right view, front view, right view. Yeah, sorry, my mistake. This is the front view, this is the right view. That's the front view, this is the right view. Okay. They don't specify the orthographic views, that's what they say. So what are the instructions? Draw to scale 1:1 and in third angle orthographic. So what does third angle mean? Okay, you have to understand when they say third angle, there's a reason why they state that. It's not for no reason. So I'm going to write down everything is where it should be. Okay, what do I mean by that? Everything is where it should be means that the top view will be on the top. The left view, if there is one, will be on the left. The right view, if there is one, will be on the right. The front view is the main view. Okay, everything revolves around the main view, which is the front view. Okay, so what do they want from us? Just to highlight, they want a sectional front view. Okay, so it's sectional in nature. On cutting plane AA, which we must identify now. Where is cutting plane AA? That's the next step. Okay. As seen from the direction of the arrow shown on the exploded isometric, the cutting plane which passes vertically through the center of the assembly, keyword, is shown on the right view. Okay, so it is telling you is shown on the right view, okay, of the pulley, part 3. So they're telling you exactly where they have this information. You don't have to go looking for it. Then they want a right view shown. Not a sectional right view, just a right view. Okay, so there's no sectioning, there's no hatching of any sorts, it's just a right view. It's the sectional front view that we have to do the most work on. Okay, is there a top view? No. Is there a left view? No. Just these two views. So understand the question, that's part 1. Okay, and highlight. If it helps me highlight. So I highlight, I write, I make notes. This informs me. So take some time here, spend 2 or 3 minutes on the question. All drawings must comply with SANS, South African National Standards 10111. Show 3 faces of the M20 nut and all necessary construction on the front view. Okay, so 3 faces of the nut, M20 nut, that's what they want. Not 2 faces, 3 faces. Okay, I'll explain that. No hidden detail is required, obviously. Add the following feature to the drawing, the cutting plane. Okay, so then they want a cutting plane from us. Label the sectional view, section AA. Okay, these are very important. Don't leave these out because marks are accounted for with these 2 things. Okay, cutting plane and the section. Don't forget them. You must read through this before you start this. It's very important, right? Let's begin. So, okay, let me go through this to explain. These parts make up a casting. This is the casting. This is the exploded isometric. This is an isometric view. If you notice, this is 30 degrees. That's 30 degrees. Okay, so clearly this is an isometric view. It's been exploded using a software program, most likely something called SolidWorks. So Autodesk makes SolidWorks, which a lot of mechanical engineers use, where you can do this. You can create this casting and you can explode it and then take a snapshot of it. Okay, so you need to understand that every component here fits together perfectly. Okay, there should be no gaps in between these things when you draw them. So here's the first thing that you need to know. Okay, this points to the front view. Now what did they want from us? A front view. Okay, this is the front view pointing this way. So when we look this way, that's the front view that we're going to see. But they want a sectional front view. So clearly we need to cut through this front view somehow, observing the cutting plane. Okay, so the front view is what we're going to draw, but obviously sectioned according to the cutting plane that's given. Then they want a right view. So if that's the front, that'll be the left. That's the right view. So we are looking this way at the casting and we're going to draw that. So the largest thing we're going to see is most likely that pulley. The first object we're going to see on the right view is what? The nut, then the washer, then the pulley, then the bush, then the bracket, then the shaft, lastly. Okay, so they've numbered them just to assist us. Now we're looking at the bracket in orthographic, the pulley, the nut, the bush, the shaft, the washer. Okay, now what I always tell my students, shout out grade 10 line 6, is that you should always start with the largest object, or in terms of drawing, start with the largest object or start with the object that everything fits into. Okay, so if we're looking at this isometric here, we can see that everything fits into or onto this bracket. This bracket is seated or bolted to a flat surface, okay, using that bolt attachment there. So everything fits into this bracket. So that's what primarily I should draw first. And after drawing that, I should start layering each component into this bracket. If I start with the smallest thing, I may not have space for this at the end of the drawing. So it's wise to start with the largest part of the drawing, the largest component rather, which is the bracket. Okay, arguably you could start with the pulley, but I would say in this case, because everything fits into that, I'm going to draw that first. Okay, then next question, what should I start with first? Because they want a sectional and a right view. So which one do I draw? Now, I tell my students to draw the sectional front view or the sectional, whichever view is sectional, draw that first. Okay, reason being, it holds the most amount of information. Okay, so it requires quite a lot. Because it's a sectional view, you have to draw every component because it's being cut. Okay, that's firstly. Secondly, it gives you the most amount of marks. So in the event that you don't finish this in the exam or test, course drawing, okay, you don't manage to finish this in the time allocated, you would have drawn the view that contains the most amount of marks. So you'd score more for this than you would figuring out the right view if you had to start with that. This counts for less marks. So always start with the thing that gives you more marks. Okay, let's begin. Okay, so where on my page should I start? This is a blank page. Where do I start on the page? That's the next question. Okay, they want a sectional front view and they want a right view. Now clearly the right view is going to be on my right because we're working with third angle orthographic projection. So right view on my right, sectional front view has to be therefore on the left. Okay, so it's by a process of elimination. Because the right view has to go on the right, my front view has no choice but to go on the left. Okay, and we said we're going to start with the sectional view first, which happens to be the front view. So that's where I'm going to start, here on the left. Okay, so normally I will measure, I'll measure about, let's do 30 mils from the bottom of the page and draw a construction line. Okay, 30 mils on the page, draw a construction line, and then let's start with our bracket. So they're saying that our bracket is 75 millimeters. Okay, mark off 75 mils. 2 construction lines. It's got a height of 20 mils at the base, and then 95 mils. Now this is a sectional view, remember, so we are cutting through this. Okay, so this is 20 mils, that's 95. There's still this aspect here. Okay, so I've drawn 20 mils high, I went 95. Now there's this part which is not given to us. There's no dimension here, so you have to look at this value and that value. Okay, this is the diameter, so from this point to this point it's diameter of 50, which is across this whole thing. From the center line to the top and to the bottom is 50. So clearly from the center line to the top, which is halfway, it should be 25. Okay, it should be 25 in essence. So 20, 95, and 25 till the top, if that makes sense. Okay, and then from here we've got a line of 30 mils. I'm looking at my front view of my bracket. 30 mils, which goes down, okay, to 50. Okay, it must go down to 50. That's what it's telling me here. This now is a center line. Okay, now I did mention this on a previous video. I said that when you're drawing a center line for the first time, don't draw it lightly. Don't draw it as a construction line. Draw it as a center line from the go. From the go, draw it as a center line, just like that. Draw it like this at the start, because you don't have to erase it. You don't have to touch it after that. Once it's done and it's correct, that's it, done. Okay, so we went 50 from here to here, 25, 25, 30 mils out. I went down. This thickness of the bracket is 20, which is given to us. Okay, there we go. So the bracket is forming, as you can see. And then 28 mils from here, I must draw a center line. Now, every center line that's on the page, there are marks for. You must draw them in a nice solid line like this. That's what we as examiners want to see. Okay, so we need to see. Now, there's a hole going through here, which is being cut through. Okay. Okay, so I'm just going to look at this. They're saying that this is the cutting plane. If you look at this closely, I'm going to highlight it. This is the cutting plane. Okay, now you need to understand the cutting plane here and how it works. This is going directly through the pulley, directly in half, this half and that half. So when we look here, this is being cut through the center. But it's not just the pulley, it's every single component. This is being cut through the center. That, okay, well, not the shaft. We don't cut the shaft. The bush, straight down, straight down, straight through. Not these two either. Okay, so if you want to know what to cut and what not to cut, at the first page in this section, the very first page of casting, mechanical drawings, there's a set of rules that tell you what you should cut through and what you shouldn't cut through. Okay, so revisit those. We don't cut through ribs. Depending on how you cut a shaft, we will either cut it or not cut it. Longitudinally, we don't cut. Latitudinally, yes, we do. We never ever cut a washer or a nut. Never, ever, 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 ever. Okay. continue. I need to draw that circle that's here. There's a hole that we are cutting through. Sometimes you don't cut through a hole, but you just need to make sure it is in the center aligned. Then you cut through it. Now, they're telling me it's got a radius, pardon me, a diameter of 12. If it's got a diameter of 12, that means it's got a radius of 6. So I'll have 6 there and 6 to the right. Okay, now I see a lot of students doing this consistently when they're drawing on a sectional view. This is a sectional view, okay? They draw hidden detail lines on a sectional view, which is wrong. You don't draw hidden detail lines here. Why? Because we're cutting through the shape in half. We're cutting through the entire thing. So these are not hidden detail. They become solid lines because you can now see the material inside the shape because it's being cut. These must change to solid lines. Okay, they are no longer hidden detail. Okay, there we go. Nice solid lines. Okay, just for the sake of time, I'm going to speed up portions of this video and I'm going to draw in solid as well. I don't recommend you drawing in solid at this stage. I recommend finishing the drawing first and then outlining in solid, but if you're confident that something is where it should be going, you can go ahead and darken it. Only if you're confident. It's much more difficult to erase once you've done in solid, so make sure you're confident. Okay, this is where the shaft is going to go through. Okay. There we go, nice and neat. Okay, you don't have to erase this construction, leave it. It stays there, it's fine. Okay, make sure you have your center lines. Make sure you have both of them drawn in. Make sure these are not hidden detail, because when you cut, it changes to solid, because you're looking at the material. Okay, do we hatch at this stage? The answer is no. Hatching takes a long time, 1. 2, if you make a mistake, you have to erase all that hatching to rectify your mistake and then hatch again, which wastes time. So what we do is hatch at the end of the drawing. Okay, what's the next thing we have to draw, or we can draw? I've drawn the bracket, I've cut the bracket. The bush goes next. I could draw the pulley, I beg your pardon, I could draw the shaft first, then draw the bush, then the pulley. Now, does the pulley go over the bush, or does it sit flush against it? That's something you need to figure out. So they give us clues here on the drawing. One of the clues would be the diameter. Okay, if you look at this length, it's 20. If you look at the length of this pulley, it's also 20. So perhaps this bush goes into that pulley and not sit flush on the outside. Okay, because that's 20 and that's 20. Now let's look at the thickness. The outside diameter of this bush is 28. The circumference on the inside of this pulley is 28 as well. Is that a coincidence? No. I think that this bush fits perfectly into that pulley. That's what I think. Okay, so it should be done like that. This should go. Mind the crazy people outside driving their C63 AMG 2012 V8 biturbo Mercedes cars. Okay, that guy does that every night. Okay, so let's continue. Okay, I said I'm going to draw the shaft next, which is what you should do. Okay, it's 5 millimeters out of here, of the back of this thing, bracket. Okay, it sticks out 5 mils. Then it measures 78 from there. Okay, 78. And that's the end of the shaft. right? I'm just going to double check. Sometimes I make mistakes here. Okay, 78. There we go. That's the end of the shaft. Starts here, ends over there. Very small shaft, very short in length. Okay, this will go there. I'm just drawing that in construction for now. Okay, and then you have an outside, there's a diameter here, which is 36, which is 18 when you divide it by 2. Okay, doing this in solid Y, I'm confident that this is how it should look. So I'll do that in solid. There we go. That's the shaft. Next thing I would draw is the bush. 20 mils from here. Does it go inside here? No, it goes here. The bush sits in between the shaft and the pulley. The bush is a buffer between the pulley and the shaft. If something happens to the pulley, the shaft will not be damaged and destroyed because the bush is in between. It's a buffer between the two components. Okay, it also helps against friction. I must look for a list of things that the bush does for the pulley. Okay, they work hand in hand with mechanical drawings. Okay, so next we have a circumference there, a diameter of 28, not a circumference, a diameter of 28. Okay, so that's 14 from here. $28 from there. Darken it, yes. Let's do it. That is your bush. Cut in half. Okay. Now, I've made a mistake. What is my mistake? This shaft does not have a line going through it. Just be careful there. Okay, this is clean going through there. There is no line going through there. Okay, the shaft goes straight through without interruptions. Okay, as for this here, there is a line here because there's a washer that sits on that side. Okay, so ordinarily you wouldn't normally have a line going through, but because a washer sits flush against this bush and the pulley sits there, I'm going to leave that line. Okay, so what can we draw next? Let's do the pulley. I mentioned before the placement of the pulley. You must be careful of that. Okay. Careful the placement of the pulley. It goes directly above the shaft. I'm just trying to get this thing to sit nicely. Okay, this is the pulley that sits over the bush. Okay, it's 20. They're saying it's got 124. Okay, that's the diameter. 124 is the diameter. Right, let's do it. Okay, so from the center, it's going to be 62. And 62. Now I'm just gonna neaten this up a little for your understanding, not mine. Just joking. Okay, then from there, Okay, so 12 mils. Now there's an indent into this pulley that's 12 mils wide from the center. Now we need to find the center. So you measure 10, you draw a center line here, you draw a center line there very lightly, and it's 12 from the center, so you have to divide that by 2 to get 6, and then you go 6 on the other side. So 12, 6 and 6, right? Okay. Now, there's another measurement here of 104 and then 72. So we got to divide these by 2 and we'll get that distance and that distance. Okay, so if this distance, this diameter is 72, half of this from here to here would be 36. That would be our radius. If this distance from here to here is 104, then from here to here would be a radius of 52. 36 and 52. If we're measuring from the center line here and there. Now, why is that important? Where does it come into play? Let me show you. There's a small indent here into the pulley from the center. Okay, so what did I say? 36 and 52. Okay, now this is what the pulley looks like when it's being cut and sectioned. Okay, there's this recess that goes into the pulley. There's a recess that goes here, then it comes back out, then it goes this way, and then that's that side of the pulley. Now, why is there a line drawn, a solid line drawn here? Why did I not leave this plain? Why did I not leave this out? Because if I'm cutting through it, perhaps there's not a line there. Well, here's the answer. When you cut through this, okay, when you cut through this and it's shown like this, you can still see the back of the pulley, the back. So we're cutting here, we're looking, this is going to be hollow, that's going to be hollow there, but we're looking at the back of it. Okay, so this has to be a solid line. Okay, if I had a 3D, I would show you. Maybe I'll insert that later on. Use some magic, some creative magic there. Okay, and show you guys. But this is a solid line. It has to be a solid line. Okay. Let's continue. What's next? Pulley done, bracket done, shaft done, this part done. What is next? Okay, we've got the washer and the nut. Okay, so the washer would be 4 millimeters thick. It's given to us. Okay, if it wasn't given to us, we'd have to work it out, which I will go through in the next lesson. Okay, next lesson, bolt construction. Some of you grade 12s need that help as well. Some of you, so you know who you are. A lot of you from line 5 and 6. Yeah, a lot of you forgot your bolt construction, and you're writing, you guys are writing paper 2 next week, if I'm not mistaken. So you need to brush up. Okay, we do not cut and hatch a washer. I repeat, we do not cut and hatch a washer. How you see it here is how it's always going to be drawn. Okay, like that. We don't even draw the 2 lines of the shaft that go through. Next is the nut. Let's draw the nut. Now, I'm not going to go into detail of the nut. I'll do that in a separate video. I'm just going to draw it. Now, when you're drawing a nut, which should be placed here, okay, you need an auxiliary view. We can't draw the side view or the front view of this nut without drawing. Now, when I say front view, this is what I mean. That's the front view. This is an auxiliary view. Okay, of the nut. Now, we need to draw this in order to project those lines back, and then those 2 circles come to get the shaft. You need to draw this to get that. Where do you draw this? That's the question. Do we draw it here? Do we draw it there? Do we draw it here and then just project that there? Here's the thing. Okay. Now we need to draw a right view, which is looking this way. Okay. The right view is going to go on this side of the page. Now, instead of drawing an auxiliary view here and then drawing a right view again here, now understand something. When I'm looking at this from the right, the first thing I see is the nut. Specifically, what part of the nut? I'm looking at the auxiliary view of the nut. So my advice is don't draw the auxiliary twice. Draw it on the right view. Even if you're not drawing the right view, we're still busy with the front. We haven't hatched. Draw it on the right view. Bring it across. Finish this. Go back to that. Okay. But now, before I draw the right view, the nut here, I can't just draw it anywhere. I need to make sure there's enough space for the right view when I'm positioning this in the center, because remember, the nut is the first thing you see. It's in the center. So I'm going to go according to the radius of the pulley, because that's my largest object in terms of horizontally. Okay, so the pulley is going to be what was it? 124. So I'm just going to make sure I've got enough space. So let's say, yeah, this is enough space for 124. That is 124 there. So whether I start here or I start there, there's enough space. So I can start anywhere along these axes. What do I do? How do I start? With the center line. Nice and solid. I'm not going to say, okay, not solid, dark. Because this is not a solid line. It is a chain line. That's what it's classified as. Chain line. Okay. Our deputy's name is Mr. Chain. Chain line. His line. Okay. Not everyone will get that joke. Okay, so here's my center line. X and Y, horizontal, vertical. I'm going to draw my nut there, auxiliary, project it to there. Okay. I'm not going to go into how to draw the nut. I'll do a separate video. Let's just say this is an M20 nut. Here's my red pen. Okay, M20 nut. 20, let's go number 1, 20 times 1,5 is equal to 30 is equal to, divided by 2 to get a radius is 15. Right. Compass broke in the last video. So I'm just going to do some YouTube magic here. As you can see, it's blunt. And I'm going to sharpen it with magic. Watch. Okay, back to it. Nice and sharp. Okay, not that sharp, but it'll do. It will do. Okay, what did I say? 15 radius. Okay, I fixed the nib of my, I got another nib for this compass, and I put a few papers underneath this page so I can hold my compass normally, as you can see. Okay, apologies for the previous video. Quick tip, place a few pages underneath the page you're working on, so when you poke this down, okay, it holds in place. Quick tip, and doesn't damage your board underneath, because this is plastic. Okay, so that's the circle of my outside. This is the third circle, big circle. Right, now they want us to show, quick tip here, they're saying they want us to show 3 faces of the M20 nut. Now, how do you determine whether you show 3 faces or 2 faces? It's the orientation of the hexagon. So if you show the hexagon this way, okay, let me just draw these two. Doing the same thing. Okay, no hexagon's complete without a nice center line. Right, if you draw the hexagon this way and you're projecting to the left, you will get 3 faces. Okay, if you turn the hexagon to on its side, well, the other way, you will get 2 faces. 1, 2, 1, 2, 3. That's how you determine whether you show 3 faces or 2. So if they say 3, you make sure you orientate the hexagon in this way. If you do it that way, you get 2 faces. Okay, so it's just a matter of manipulating the set square this way versus this way. Okay, tangent lines. Okay, these constructions are a little dark, so I just erase them slightly. I'm not going to explain what I'm doing here. I'll do it in a separate video. But what I did was, I have the diameter of the shaft on the left. I just brought the diameter of the shaft across to this point. And now I'm going to place a compass here and draw a circle. Instead of measuring, it's faster. Okay, there we go. 20 times 0.1, that is 2 moles. 2. Okay, as I said before, guys, I'll explain this. I'll do another video explaining bolt construction. Okay, there we go. There's your nut. Take it across. A lot of you seem to battle with this bolt construction. Don't stress, I got you. I got you, fam. Ish, making mistakes here. Okay, there we go. It's not the neatest. There's a light that I'm waiting for, that I need before I can start doing these properly. I'm waiting for some equipment, guys. Bear with me. Okay, this part is very important. All these, you see all these things here, the end of the shaft with the 45 degree, with these lines here of the thread. Each one of these lines, as well as the 45, counts for a mark. There's around 8 to 12 marks, depending on which paper, which year, that are counted for this section alone. So don't skip this. Don't not draw it. Okay, and it'll always be shown here. You'll always have this protruding out of the nut. It'll never be below or way out. It'll always be a few millimeters outside of the nut with the washer. Okay, this is important. Make sure if your nut is going over this, you've done something wrong in terms of your length. So just be careful there. All right, this is completed almost. We need to hatch and we need to label this, but that's the nut and the washer and the shaft drawn. Okay, now I'm going to show you my fancy tools. When I studied back in, I'm not going to say which year, I bought this set square, which I used when I studied. I didn't study teaching, I studied something else, and I used this tool, which was very accurate back then. Okay, hatching. Now, every component needs to be hatched differently depending. Okay, if it's a different piece of material, okay, all these are metal firstly. Okay, so metal hatching is line space, line space, line space. It's different from silver hatching. This is metal hatching. Okay, now the pulley is one part, so we're going to hatch the pulley the same. And when I say the same, I mean the same kind of hatching. Okay, because it's one type, one part here within this mechanical casting. See, I nearly say assembly. Now this bracket is another part, but it's still made of metal, so you got to hatch it with metal but differently. So I'm going to go in the opposite direction, 45 degrees. Okay, now that is going to indicate the examiner that this is a different piece of metal and not the same. Okay, but that poses another question, which I'll get to now. This poses another question, which I'll get to in a bit. Okay, now I've hatched the bracket that way. I've hatched the pulley this way. I still have the bush to hatch. Okay, see, I missed a bit here. Okay, now I still need to hatch the bush, but what do I do? Because I hatched that and I hatched this. So now there's no other direction on this. So how do I hatch it? Here's your answer. Okay, you hatch this, you can hatch the same direction, but your increments between lines or your spacing between the lines must be different. You need to adjust the spacing, right? So can you see now this is closer together than this, which tells the examiner that it's a third piece of material, a different piece of material. Okay, now why am I hatching the top of the bush the same? Because this is one bush. So this would be the same as this. If there were two bushes, then the bush next to it would be in a different direction, but you could use the same spacing. Does it make sense? Hopefully it does. Okay, pause this video, make it make sense. Okay. Now, we've completed this. Done, perfect. We need to now label the sectional view section AA. Now they haven't specified how thick the label must be, what width from top to bottom it is, but usually for labels it's 5 millimeters. Okay, 5 millimeters. Okay, and then other things are 3 mils. So for labels, for titles are 5 mils, labels are 3. So for the sake of accuracy, okay, I'm going to use 5. Let's use 5. Just because they didn't specify. Okay, it must be at the bottom of the drawing, remember. Block print, with capital, in other words. Okay, section AA. That is your sectional front view. Next thing we need to draw is the right view. Now, at this stage, the right view is going to be easy because all we do is project everything across. Okay, so first things first, I'm going to draw the pulley. Nice and solid. Bring the line of that indent or recess across. Bring the washer across. It's quite a few circles to draw. Make sure you have a compass and it's sharp. Washer, pulley, 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 recess in pulley, pulley. Okay. Next thing to draw is the bracket. Which is 50 mils. 50 mils across. Extend this center line. See, I'm just projecting those lines across. Now you don't have to project the line in construction. You can just line it up and draw that. You don't have to actually draw the line projected. Saves a bit of time. Okay, that we have to draw. No hidden detail is required, so we don't have to show this circle here because they stated no hidden detail. But there's one more thing here. They're saying they want the cutting plane AA. Okay, now this is the cutting plane. Now you don't show this line on the sectional view. We don't show a cutting plane on a sectional view. We show it on the view that's not sectioned. Okay, so we're gonna draw this just as it is here, with the arrows, with everything else. And I'm also going to show you the mark weighting. Okay, so I can use this, draw an arrow here. Okay, next you need to make this, give this a little bit of thickness, this to make it a cutting plane. Okay, so the center line is drawn, just give that a little bit of thickness, just like it is here. Replicate this is what I'm saying. And then draw the letter, the alphabet A. Okay, you'll get a mark for the letter, for the arrow, and for the thickening of that line. Do the same thing at the bottom. Okay, have I forgotten anything? I have not. This is the bracket, that's the pulley, that's the nut, there's the washer. You're not going to see the back of the shaft. There's no hidden detail. The bush is hidden, okay? But I also want to do this. I want to state that this is a right view, okay? I don't think they say you need to label it, but it's good practice to state this is a right view, okay, to get your marks. Now, is there anything else? No, they just wanted the cutting plane. They wanted no hidden detail, sans, label the section. Guys, that's it. If you made it to this part of the video, if you waited all this time, 3 hours into the video, thank you for watching. Make sure to like the video and subscribe for more videos. The next one I'm going to do is on bolt construction, bolt, nuts, washer, all those things, okay, which some of you grade 12s need to know, judging from your assemblies that I've just marked. Shout out to line 5 and line 6. Okay, thank you for watching.